Usually whenever you're working with polynomials, we're going to be dealing with one variable at a time. And later we're going to call these functions whenever you get more towards college algebra. But it is possible to have more than one variable and it still be technically called a polynomial. In that case, it's a little bit different to try and talk about the degree of the polynomial. Because remember, the degree of the polynomial is the highest power of the variable. But if you have more than one variable, it's kind of like, which one am I looking at? Well, you got to look at all of them. So let's talk about this problem here. It says identify the degrees of the terms and then the degree of the polynomial. So let's look at this as terms first. Let's identify each one of our terms. First of all, we have 2a squared b. So I'm going to write that down, 2a squared b. Then I have another term of 10a to the fourth b. Then I have a third term here, negative 9ab. And then my last term here is a positive 6, so I just have to write 6. Okay, now let's look at each one of those degrees, the degree of each one of the terms. Here we have an a squared and also a b, which is technically to the first power. Because there are two different variables, we have to add them together to get the degree of this term. So this would be a degree 3 term. Here we have a power of 4 and a power of 1, so that would make a degree 5 term. Here we have a first power and a first power, so when we add those together, that would be a degree 2 term. And in this one, because this is just a plain constant, technically we have an x to the 0 power, or an a to the 0 power, or whatever you want to call it. So this technically has a degree of 0. Now, once we look at this, we can try and figure out what the degree of the entire polynomial is. The degree of the polynomial, I'm going to abbreviate it as poly, is the highest degree of each term, or the highest power of the variable, which in this case would be a 5. So the degree of the polynomial is 5. Now we can also combine like terms even if we have more than one variable. That is not a problem at all. We just have to look for like items. So in our first term here we have a 14y cubed. Do we have any other terms with just y cubed in it? No. So 14y cubed cannot be combined with anything else. Here we have a negative 6. That's just a plain number. Do we have any other plain numbers here? Yes, we do. A negative 10. So we can combine this negative 6 and this negative 10 to make negative 16. And now we're done with those. Now lastly here I have an a squared b squared. Well, look over here. I also have a b squared a squared. Because that's multiplication, those could be flip-flopped and it would be the exact same thing. A squared b squared is the same thing as b squared a squared. So these are like terms then that can be combined. So positive 3 of those minus 19 of those would be minus 16 of those a squared b squareds. That is combining like terms with more than one variable.